God bless you wherever you are. Thank you once again for joining Initiative Smart Class today too for another exciting and interesting topic, which is logarithm involving equations. Let me first indicate that this particular question is a question that appeared in the just ended NAPTEX NOVDEC exams. We'll be very glad that you take your pen and then your paper as you have always been doing, and then join us to go through the solution successfully. We pray that by the end of the solution, you will be able to get all the tricks that you will need, if not all, most of the tricks that you will need to go through questions like this. The question actually wants us to find the values of x given this equation. So let's go to the board and go through the question and present the solution. We have log of 2x squared plus 5x minus 2 to the base 10 is equal to 1. And the question says that we should find the values of x. In fact, that is the demand of the question. We are supposed to find the values of x. In fact, when it comes to indices and logarithm and a topic like circle theory, if you don't know the properties, if you don't know the laws, there is no way that you'll be able to solve the question and get an answer. So it is better you familiarize yourself with the properties and also the laws before you can solve questions like this. Now, let's look at the property we will need to solve this particular question. The only property for now that will be of importance to us, especially at this moment, is the property that says that log of a number to the base of the same number is equal to 1. Log of a number to the base of the same number is equal to 1. We need this property to be able to solve this question. One can equally use the definition of logarithm to also solve this question. The definition of logarithm can also be used to solve this question. And what do we mean by the definition of logarithm? If we have log of a to the base b is equal to c, by definition, we are saying that a is equal to b to the power c. A is equal to b to the power c. That means the a here is equal to the base to the power c. In fact, this is the definition of logarithm. So it is either we use this property or we use the definition of logarithm to solve the question. And by using this property and using the definition, we'll get the same answer. So if we are using this property, how do we progress? And again, if we are using the definition of logarithm, how do we make progress? Let's try to use the property that says that the log of a number to the base of the same number is equal to 1. By applying this particular property, we can equally say that then if I have log of 1000 to the base of 1000, then the answer is 1. That is the meaning of this property. Again, if I have log of 4 to the base 4, the answer is 1. If I have log of 5 to the base 5, the answer is 1. And look at this critically. It has a relationship with the definition of logarithm here. We are saying the log 4 to the base 4 is equal to 1. Log 5 to the base 5 is equal to 1. Now look at the definition of logarithm. It says that the value here, which is 5, is equal to the base to the power c, which is 5 to the power 1, which makes the definition true. This is the definition. This is the property you know. And by applying the property, we can see that it has a link with the definition of logarithm. Now we are saying that log of a, I'm stating it again, log a to the base b is equal to c. By definition, a is equal to b to the power c. And if we are saying that log 6 to the base 6 is equal to 1, by comparing, a is equal to 6, b is equal to 6, and c is equal to 1. So look at the definition here. A is 6, b is also 6, and then c is equal to 1. That means 6 is equal to 6 by applying the definition of logarithm. So a student is at liberty to use either the property or the definition of logarithm. And those procedures can lead the student to get the same answer. I believe strongly for now, if you are following me, you have really understood this particular concept. As in, either using the property or using the definition of logarithm to solve the question above. Now let me clean it and then let's start the solution. Let's start with the solution of the question. This only helped us to understand that particular property and also the definition of logarithm. If the understanding is clear now, then we can say that from this particular question, log of 2x squared plus 5x minus 2 to the base 10 is the same as log 10 to the base 10. Is the same as log 10 to the base 10. Why? Because the log of any number to the base of the same number is equal to 1. We have converted the 1 into log 10 to the base 10. And the reason for doing that is, when you look at the left hand side, the expression over there has base 10. The expression here has base 10. So it will be out of order to write 1 as log 4 to the base 4. It will be out of order to write 1 as log 4 to the base 4. We want to express the right hand side and the left hand side to have the same base. And at the same time, we should not commit any mathematical error by expressing the left hand side and then the right hand side to have the same base. In fact, we have not committed any error by writing 1 as log 10 to the base 10 because the property gives us the right to do that. Okay, if that is well understood, then we also need to understand that when we are dealing with equations involving logarithm, then we should also know that the log of x to the base a equals equals the log of y to the base a. When you have log x to the base a and then log y to the base a, this implies x is equal to y. Others will say the log to the base a and the log to the base a will cancel themselves. But normally what we say is that by taking antilog of both sides, by taking antilog of both sides, the log a, we will drop the log a here, and then we will drop the log a here, and then x will be equal to y. That is the expression here, and the expression here will be equated. So let's take note of this particular rule 2. The log of x to the base a is equal to the log of y to the base a. Taking antilog of both sides, the log a will cancel the log a, and then we'll be having x is equal to y. We are applying the same concept here. The understanding, we are applying the same thing here. We can see we have base 10 here, and then another base 10 here. And we are taking the whole of this as one expression. And we are taking the whole of this as another expression. So since the base are the same at the left hand side and also the right hand side, then it means we can take antilog of both sides. So taking antilog of both sides, it means the log 10 and the log 10 here will cancel out. It will vanish. We will drop them. And that we will be at liberty to equate 2x squared plus 5x minus 2 is equal to 10. Because we have dropped log of 10 and log of 10. They are the same. We found antilog of both sides. So the equation here, the logarithmic equation, has reduced to a quadratic equation. We have 2x squared plus 5x minus 2 is equal to 10. We have to make sure that we send all the terms to one side and then equate the right hand side to 0. And that will give us a complete quadratic equation. And that will be 2x squared plus 5x minus 2 is equal to minus 2 minus 10 is equal to 0. That is when you move 10 to the left hand side, it becomes negative because originally it was positive here. So when you move it to cross the equal sign, it becomes negative. And this will be 2x squared plus 5x minus 12. which is equal to 0. 2x squared plus 5x minus 12, which is equal to 0. So now we have a quadratic equation from the logarithmic equation. Now, with this, we need to learn how to solve a quadratic equation. Let me make a comment here before we tackle the quadratic equation here. We know the general quadratic equation is given by ax squared plus bx plus c is equal to 0. This is the general quadratic equation, that is ax squared plus bx plus c. If you want to solve this quadratic equation, you can use the normal factorization process. You can use method of completing the square, and you can also use what we call the almighty formula. You can also use what we call the almighty formula. What we do is that the first thing to do is to multiply the coefficient of x squared by c. What we mean by the coefficient of x squared is the value that comes before the x squared. The value that comes before the x squared. That is what we mean by the coefficient of x squared. In this case, it is a. So you multiply this coefficient of x squared by c, the constant, and then you will get ac. You will get ac. In our question, the coefficient of x squared is 2. And then the constant c is negative 12. So by multiplying a by the constant c, we are getting ac. Specifically, 2 here multiplied by negative 12 is giving us negative 24. Negative 24. Sometimes students find it very difficult to find the factors because they only concentrate on the negative 12. They fail to multiply 2 by the negative 12 before finding the factors. In fact, you can only go ahead to find the factors when the coefficient of x squared is 1. But if the coefficient of x squared is 2, what you need to do is to multiply 2 by the constant, and that will give us negative 24. After getting this negative 24, you find two numbers such that when you multiply, you will get negative 24, but when you add, you will get positive 5. Two numbers that when you multiply, you will get negative 24, but when you add, you will get positive 5. In fact, what I've always been doing is to draw my tree. 24. You know, 1 times 24 will give you 24. But we don't have any combinations that can lead to positive 5. Again, we can also look at 2 and then 12. 2 times 12 will give you 24. But you can't get any positive and negative combinations that will give you positive 5 and then negative 24. So we can go further and then try again. We can try 3 and then positive 8. That is 3 and then 8. Here we have everything here positive, but you can still do your manipulations and see whether you can get negative 12 out of this and that. Negative 24 out of 3 and 8, and then positive 5 out of 3 and then 8. It is possible in the sense that you need negative 24. So what you need to do is to negate one of them, because negative times positive will certainly give you negative. You negate one of them such that when you add, you will get positive 5, but when you multiply, you will get negative 24. So by doing your manipulations, you can see that by choosing positive 8 and negative 3, we can get this combination can help us get what we need. 8 times negative 3 will give us negative 24. And then by adding 8 and then negative 3 will give us positive 5. That means 8 and negative 3 will satisfy the equation. Will be the best factors to satisfy this equation. By getting these factors, you need to split the center into 2 by using the factors. Split it into 2 by using these factors. What do I mean by split it into 2? Split it into 2 is in such a way that when you add 8 and negative 3, you get positive 5. And when you multiply 8 and then negative 3, you get negative 24. And this should be the next level. This should be the expression on the next level. That will be 2x squared plus 8x minus 3x minus 12 is equal to 0. 2x squared plus 8x minus 3x minus 12 is equal to 0. This is the expression. 2x squared plus 8x minus 3x minus 8x minus 3x will take us back to positive 5x. And that makes the equation true. At this level, we can do a factorization. You can simply do a factorization. A number that can go into 2 at the same time can go into 8. And that number is 2. You factorize the 2 outside. A number that can go into 2 and 8 is 8. Is 2. After that, you choose a letter that is common to both sides, and that letter is x. So 2x will come out. Here we'll be having, if you want to know what should be here, you need to divide these 2x by each term. You need to divide these 2x by each term. By looking at this, if you are dividing 2x squared by 2x, these 2 will cancel these 2, and then x will cancel this x. You'll be left with only one x here. Plus, you still do your division. 8x divided by what is outside. By dividing, what I mean by dividing 8x by 2x is 8x divided by 2x. This x will cancel this x. And 2 goes into itself 1, into 8, 4. So that is the meaning. By getting the factor out, you divide these terms by the factor that is outside the bracket. So we'll be having 4 here. We'll be having 4 here. Now, similarly, when we come here, we have negative, negative. And the number that is common to both sides is negative 3. Negative 3. Then you introduce your bracket. If you want to know what should be here, you need to divide this term here by negative 3. Divide this term by negative 3. That is negative 3x divided by negative 3. This negative will cancel that and you'll be having positive x. Now, what do we write here? If you want to know what to write here, divide this term by the common factor. So that is, in that case, negative 12 divided by negative 3. This negative will cancel this negative. 3 goes into itself 1 into 12, 4. So plus 4 plus what should be here is equal to 0. Is equal to 0. So the idea is to divide the terms by the common factor you have factorized out here. Divide the terms by the common factor. And you will see you'll be having same expression in this bracket and then same expression in this bracket. What we tell students to do at this level is to choose one of the expressions in the bracket. And that will be x plus 4. After which 2x minus 3 will also be in another bracket. That is 2x minus 3 will also be equal to 0. So we have x plus 4 in one bracket, 2x minus 3 is equal to 0 in another bracket. In fact, the question says we should find the values of x. The values of x. At this level, you equate each expression to 0 and then you make x the subject. You equate each expression to 0 and then you make x the subject. Now, let's try and equate them to 0 and then find the values of x and find the values of x. So this is what happens. We have x plus 4 and then 2x minus 3 is equal to 0 from the solutions we've done so far. Now, we want to find the values of x because that is the demand of the question. X plus 4 is equal to 0. And then we have 2x minus 3 is equal to 0. X is equal to negative 4. When x crosses the equal sign, we'll be having negative 4. And then here we have 2x minus 3 is equal to 0. And then we'll be having 2x is equal to positive 3. That is negative 3. When it's positive, it becomes positive. You divide here by 2. You divide here by 2. And these 2 will cancel these 2. That means we have x is equal to negative 4 and 3 out of 2. The meaning is that when x is equal to negative 4, it will make this logarithmic equation true. When x is equal to 3 out of 2, it will still make this equation true. Although we don't have logarithm of a negative number, but let us be clear on this, that the fact that x is equal to negative 4 doesn't mean that we are looking at log of a negative number. The value of x here represents a number that will make this particular equation true. That is the point. So what we need to do for now is that we need to verify the authenticity of our answers. One interesting thing about logarithm, equations involving logarithm and then indicial equations is that after getting your values, you can verify whether the answers are correct or not. So let's try to see if when x is equal to negative 4, our equation will be true. Let's find out if when x is equal to 3 out of 2, our equation will be true. Now, let's substitute x is equal to negative 4 here and check whether we'll be getting 1. Log of 2, x is equal to negative 4. So wherever we see x, we put negative 4 squared plus 5 neg 4 minus 2 to the base 10. The meaning is that after evaluating this, we are supposed to get 1. That is the meaning. Because from our solution, x is equal to negative 4 and 3 out of 2 will make this particular equation true. We have substituted negative 4. We want to check whether truly we'll be getting the 1 there. And this will give us log 2 negative 4 squared is positive 16. Please, if you are using your calculator to find negative 4 squared, don't just enter negative 4 squared. The negative must be in a bracket. If you just enter negative 4 squared, it will give you negative 16. And that will make your answer wrong. Negative 4 must be in a bracket squared. And that will give us positive 16 here. Plus 5 times negative 4 will be negative 20 minus 2 all to the base 10. In fact, we are working towards something. We want to find out whether when x is negative 4, we'll be getting positive 1. 2 times 16 is 32. 2 times 16 is 32. And this will give us log 32 minus 22 to the base 10. Log 32 minus 22 to the base 10. Because negative 20 minus 2 is negative 22. And 2 times 16 is 32. Now we have 32 minus 22 is equal to 10. So log 32 minus 22 to the base 10 is equal to log 10 to the base 10. And the log of any number to the base of the same number is equal to 1. And that makes the equation true. That is, if x is equal to negative 4, the equation is true. Let's try 3 out of 2 to check whether that one will also make the equation true. 3 out of 2. Let's check that one too. Let me clean this, and then we check when x is equal to 3 out of 2. Are we going to get 1? X is equal to 3 out of 2, and then we work towards getting 1. If we are not able to get 1, it means our answer would be considered as invalid, will be considered as not right, and then the answer will not be correct. So every time after solving any question involving equations, it is better you substitute the answers to find out whether you'll be getting the same thing at the right hand side. So we are considering x is equal to 3 out of 2. When x is equal to 3 out of 2, let's check whether it will make the equation true. And that will give us log 2 here. Wherever you see x, you put 3 out of 2. 3 out of 2 all squared plus 5. 3 out of 2 minus 2 to the base 10. This time around, we are solving this to get our 1. And this will give us log of 3 out of 2 all squared will give us 2 multiplying 9 out of 4 plus 15 out of 2 minus 2. It will give us this. 2 log into bracket 2 is multiplying 9 out of 4 plus 15 out of 2 minus 2. Someone will wonder how we were able to get 9 out of 4 and then 15 out of 2. But here, this part is strictly a property in indices. That if you have a out of b all to the power n, this is equal to a to the power n and then b to the power n. That means if you have 3 out of 2 all squared here, is the same as the 3 will take the power and the 2 will also take the power, making it 9 out of 4. So this is what happened here. by moving from this level to this level. The 3 squared is 9, and then the 2 squared is 4. And here is multiplication of fractions. 5 is multiplying 3 out of 2. The 5 is the same as 5 out of 1. So multiplication of fractions, if you have A out of B multiplying C out of D, A out of B multiplying C out of D, we use top, down, down. That is AC all over BD. The top will multiply and then the down will also multiply. Top, down, down. And this is the same as 5 times 3 is what? 15. 1 times 2 is what? 2. So when you multiply the numerators and then you multiply the denominators, it will lead you to 15 out of 2. Let's look at the next level then. Let's remember it is to the base 10. This 2 here will cancel this 4, and then we'll be having 2 here. The next level will be log of 9 out of 2 plus 15 out of 2 minus 2, all to the base 10. Let us remember what we are doing. We have already gotten our answers, but we want to verify whether the answers are true. The answers make the equation true. This is equal to, when you are dealing with fractions, when the denominators are the same, you just choose one and then you add the numerators. And this will be equal to log 9 plus 15 will give us 24. So log 9 plus 15 will give us 24 out of 2 minus 2. Since the denominators are the same, we just add the numerators because they are like fractions. 24 out of 2 is 12. And this will give us log 24 out of 2, 12 minus 2 to the base 10. 24 divided by 2 is 12, minus 2 to the base 10. And again, we know that 12 minus 2 is 10. And this still gives us log of 10 to the base 10. But the property is still working. If you have log of a number to the base of the same number, it is still 1. Whenever I will entreat you to check your answers, whenever you have questions on equations, every equation, if you get the values of x, make sure you go back to the equation and try to check whether the left-hand side is equal to the right-hand side. Remember, like I told you before, this particular question is a question that appeared in the just ended NAPTEX NOBDEC exams. We don't know whether a similar one will be coming in that of the WASI. So take it serious, go through the process, and make sure if you have a similar example, you can apply the principles to solve the questions and get the correct answer. It is better you solve your problems now than to wait last minute before finding yourself wanting when it comes to topics like indices, logarithm, and then trigonometry. Once again, may God richly bless you wherever you are for spending time with Initiatives Math class. We will continue to entreat you to like, follow, and then share the page. And we believe strongly by watching the videos and making time with us, you will overcome your fears in mathematics. God richly bless you. Bye-bye.